All right, this is 8-6 digit problems. I'm going to hold off on the coin problems because we taught a majority of that. We talked about that the other day. So we're just going to cover digit problems. All right. Here's a typical digit problem. Take the time, write the problem down so you know what to do in the future. So you can refer back to this in your notes. So pause the recording. All right. So let's just take any two-digit number and see what it's made up of. Okay? A two-digit number. We can take... This has nothing to do with the problem. Let's take a 56. Okay? What makes up 56? Piper?
50 and
6. 50 plus 6. We can rewrite it like that, right? What makes up 50? Sarkis?
25 and 2.
Anything else? What makes it 50 in terms of place value? Piper?
25 plus 25.
What makes it 50 in terms of place value, I said? Not give me factors. What makes it 50 in terms of place value? Yeah. The tens place. So how do I make that up? Using place value. What am I doing to the 5 to make it 50 and not 5? Michael?
Multiplying by 10.
Multiplying it by 10. So I could say this is also made up of 10 times that digit. 10 times that digit. Okay? Stop. So now I've got plus 6. What about 83? Yes.
It could be 8 times 10 plus 3.
So I can do 10 times 8 plus 3. Okay? What's next? What about if I had 31? Do you need to leave, Oscar?
No.
Because you're going to go to Miss Delosia's in a minute. Okay, what if I have 31? Christina?
10 times 3 plus 9.
Yeah. So do you notice that every time this digit right here is multiplied by 10, and this I just add the one as a 1. We're going to do that, only I don't know the names of the digits. Here's my original number. I don't know the first digit, and I don't know the second digit. But here's my number. That's the original number. So what does X stand for? Which digit? Sarkis. Mathematically. What does X stand for, Iman?
X stands for 10.
Not tenth. Okay, Rogelio. Tens. Digit. It's the tens digit. Listen, tens versus tenths. The tenth is right here, to the right of the decimal. It ends with the th. Hundredth. You know, it's tenths, hundredths, thousandths, 10,000th with the th. So, is to the right of the decimal. So, with that in mind, we know that this X is going to be the tens digit. And the Y is going to be the, Luke? Ones digit. Okay, so I'm going to define that. Okay, I'm going to define that. So X is the tens digit and Y is the ones digit. I don't know what the number is, but I know we're going to call the X the tens digit and Y the unit digit, the ones digit. So the original number looks like what? What does it look like? Sarkis.
So it would look like XY.
XY. If I reverse that number, what's it going to look like? If I reverse those digits, Michelle, yx. But really, the value of this is 10 times whatever x is plus a y. What would the value of the reverse be? Sarkis?
Y plus 10x.
Nope. What's in the tens digit? Here. X is no longer in the tens place. Okay, Sarkis again?
So it's 10y plus x.
Yes, this is going to be 10y plus x. So whenever they talk about the y, we're going to use this. Whenever they talk about the x, we'll use this. The value of them. Okay, now this is really about translating. Okay? The first piece that we can translate is this. The sum of the digits is 11. The sum of the digits is 11. David?
That could be 5 plus 6. Nope.
Algebraically, hon. We're doing it algebraically. Go on, try again.
Okay. 10.
We don't know numbers. You have to solve numbers. There should be no numbers at this point except for one number.
Okay, so it's
Based on our definition of let x be the tens digit and y be the units digit.
x plus y.
No, Michelle?
X plus y equals 11.
That just says the sum of the two digits. Doesn't ask for the value. The sum of the two digits is 11. X plus y. We've already said our tens digit is x. That's the tens right there. And the y is the unit digit. Then it says there's two digits. The sum of them equal 11. Now, right here in your word problem, and these digit problems don't really veer from this pattern. They're usually always written. Reverse is 27 more than original. Reverse is 27 more than original. And I pull those words out. Reverse is 27 more than original. Now, I added a couple things here. I had erased the value of the original number and I added it back in. So you should already have that there. And the value of the reverse is 10y plus x. And then I pulled out my words. Reverse is 27 more than original. Yes.
I'm a little confused.
We're going to take all confusing questions. We're going to go through it first once. Okay? And then we're going to go back to where we're getting. I want you to go through it once. Okay, so I said I'm pulling those words out. Now I'm using my value statements, not the original digits. What do I put for reverse? Luke?
10y plus x
Perfect. Is?
equals
Good. Now, how do I show 27 more than original? 27 more than original. Piper?
27 plus xy.
Nope. It's value. In this second sentence, we're using the value of it. Ben?
I had a question.
Okay, I'm looking at... hold on to that. Write it down. I don't want you to forget it. I want to go through, finish the process. Sydney?
Is it maybe equal to
10x plus y plus 27.
Close. You're very close. Oh, yeah. 10x plus y. You're right. You're there. 10x plus y, the original number, which is, 10x plus y, that's the original number, more than, it says 27. 27 more than. Okay, now I have two equations. Here are my two equations. So what can I do to solve this? I have two variables. What can I do to solve it? Let's go with David.
You could subtract 1y from both sides of the equation.
Good. Let's subtract x. How's that? And we get y equals 11 minus x. Now what would I do, David?
Then you would plug that into the equation.
We don't plug, we
Substitute
into the equation, and so it's going to read
10 times the quantity of 11 minus x
good.
plus x equal to 10x plus 11 minus x plus 27.
Good. And now we're going to simplify.
Combine like that.
Somebody else? Peyton?
This is 50.
Okay, and we get?
Oh, 111.
No, 100.
Oh, yeah.
What? 10 times 11 is? 110. And 10 minus x is?
Minus 10x.
Yep, plus x. And then we just write everything else down. You could combine your like terms on the right side. 10x minus x makes how many x's?
9x.
9x plus 27 and positive 11 is 38. I'm combining the 11 and the 27. Next is negative 10x plus x makes negative 9x. 110 minus 9x. And then I'm going to get my x's all to one side. I'm going to add 9x to both sides. Subtract 38 from both sides. And divide 18 by both sides of the equation by 18. And we get x equals 4. Okay, so now how can I figure out, what did we just find? What did we just find? Piper?
The reverse of the number?
No, we didn't find that. We only found x. And what does x represent? You wrote the definition before. Matthew? We found the tens digit only. We found the tens digit, which is 4. Okay? So now what can we do now? Sadat.
Well, you substitute the x and the y equals 11.
Okay? So we go back to this original equation, y equals 11 minus x. Substitute the 4 in, and we get y equals 7. Okay? So if my original equation, my original number, I'm sorry, not equation, my original number is xy, and we know what x is, and we know what y is. What's the original number? Luke.
47.
The original number was 47. And we go back to that word problem. Sometimes they might say, find the original number, and sometimes they might say, what are the digits? So that's the difference between your answer. Okay? The tens digit is 4, and the One's digit is 7. Yes, Piper.
Didn't the original problem say to find the reverse?
Hold on. It used that as a clue. Let me, can I erase this? Okay. The original problem said the sum of the two digits is 11. If the digits are reversed, the new number is 27 more than the original. Find the original number. That's what it said. So, in the original problem, it gives you two lines that help you to figure it out. This one and this. Does that make sense? It's not asking you to find it. This says find original number. It's usually like the last line in a word problem will tell you what the goal is, what they want out of you. Yes, Kiana.
So when you said let x equals the tens digit, is that why you put 10x plus y for the value of original number?
Yes. Because if x is the tens digit, let's say we said our original number is this. That means this is 10 times x plus a y. Just like when I have 56, this means 10 times 5 plus 6. Okay, other confusions? Okay, let's try it again and see if we can do it. Okay? This gets easier because it's just learning, for me, it's just learning a process. It's always the same. It's not going to differentiate the way motion problems do. With motion, there's so many different, there's so many dynamic situations that can arise. Your distance is different. Your time is different. Your speed is different. So, all right, let's try one more. It's always going to be the same with digit problems. Okay. Okay, what are we going to call? The sum of two digits is 6. Step 1, what do I need to do? Sadat.
You write x plus y.
No, not yet.
You identify the problem, like you circle.
We define our unknowns. We define our unknowns, and so what are our unknowns?
The sum of the two digits.
The first thing I did was give a definition. Who remembers how to define your unknowns? Luke.
You say let x be.
You have to tell us the definition of x and tell us the definition of y. So what is x going to equal? What does it stand for?
The
Tens digit. The tens digit. So, Sadat, what would the y stand for?
The unit number.
Yep, the unit or the ones digit. Okay, now, what does the original problem, what does the original number look like? Oscar? If x is my tens and y is my ones, what does...
XY?
It looks like an xy. What does my reverse number look like? Kiana?
yx.
Yx. Can we translate anything without doing anything at this point? What's the easiest to translate? I want to hear from somebody else. Sarkis, somebody else. How about Nicole?
So
Without finding any value, making any value statements, what's the easiest to translate there?
X plus Y equals 6.
Perfect. The sum of the digits is 6. Okay? The sum of the digits is 6. Okay, now, what is the value of the x digit? What is the value of it? Somebody else that I haven't heard from. Matthew? What's the value of the x digit? Sean? In x, here's my original number right here. What is the value? In xy. X is always going to be equal to what? 10 times x. 10 times x. But how do you get a 2-digit number? Kiana?
Are you asking us to do an equation for the math?
No, I just want the value of the original number. Sarah?
10x plus y.
10 times the x plus a y. 10 times the x plus the y. That's the value of the original number. Kiana, what would be the value of the reverse number?
10y plus x.
Perfect. Now, what am I translating from the rest of the problem? Cedric, do you know what we're translating from the rest of the problem?
Oh, we're gonna reverse.
Okay, reverse. I'm going to underline. What words do I need? Reverse
Reverse is and more than.
is just more than.
More than the original.
That, okay, you need one more thing.
36.
36 more than original. You needed that 36. So those are the words I'm pulling out. Reverse is. Now, who can help me translate that? Maddie. Okay, but what value am I putting down for reverse?
10y.
Is, please. Okay, somebody else for 36 more than original. Armando.
10x plus
Close. Oh yeah, 10x. You're right, I'm wrong. 10x, what?
10x plus y plus 36.
Right, I was going because this is the original value. Plus 36, he says. He put the plus because it says more than. It's not going to hurt us if it says more than, but if it says less than, that might be a problem. All right. So now I've got my two equations. And now we have to use a system to solve it. Oops. Okay, what would I need to do to solve it? William.
Subtract x from both sides.
And we get? What we get?
Oh, y equals 6 minus x.
Okay. And this time we're going to substitute for?
Y.
So how's it going to read?
10 times the quantity of 6 minus x plus 6 equals...
Plus what?
Plus x equals 10 times the quantity of 6 minus x.
No. 10 times.
10x plus 6 minus x plus 36.
Good. There we have it.
Good job, Michelle.
Now, oops, we're going to simplify. Simplify. How about Matthew?
We want to simplify, so 10 times 6 is 60,
Uh-huh.
and 10 times negative x is negative 10x.
Mm-hmm.
X equals 9x plus 42.
So he's combining like terms. 9x plus what?
42.
Okay. Next step. Jason.
Next step, you combine my terms. It's, I think you add x
And
9x.
how about first you combine on each side?
Oh yeah, okay. Negative 10x plus
Good.
And, yeah, then,
Let me have somebody else. So then I'm adding 9x. Oh, sorry, it just jammed forward. Okay, get all my x's now to one side. I end up with 60 equals 18x plus 42. Subtract 42. Divide both sides by 18. And x is equal to 1. X equals 1. Okay, so if x equals 1, what are we doing next? Matthew?
Y equals 6 times 1 to the power of 1 and for x and then y equals 5.
Okay, and what is the original number? If I know my x is 1 and my y is 5, what is my original number, Peyton?
The original number is
15. The original number, for some reason my PowerPoint doesn't do that, is 15. Because if it's x and y. So those are digit problems. Okay. Now see if you can do the next one on your own. Pause the recording as I move ahead. Remember, don't forget to define your unknowns.
How long are you usually?
All right, now check your work. First equation is x plus y equals 13. Next equation, 10y plus x equals 10x plus y minus 3. Substitute. And now our x digit is 7. And when I substitute into y equals 13 minus x, I get 6. So our original number was 76. Seven's a tens digit. And that's the digit problems for today.